Hello everyone. We now proceed to part 2 of our topic, properties of fluids. No? So I ended up with this slide, which is a specific gravity. No? Let's answer a problem with regard to the properties of fluids that I have discussed previously. Alright, so here's the first problem. If we have 6 cubic meters of oil weighing 47 kilonewtons, calculate its specific weight, density, and specific gravity. Alright, so let's analyze. So we have here the weight of 47 kilonewtons with a volume of 6 cubic meter. No? So 6 cubic meters of oil weighing 47 kilonewtons. And we are asked to find the specific weight. To calculate the specific weight, denoted by gamma, density denoted by rho, and specific gravity denoted by Sg. Solution to the problem: recall that the unit weight or the specific weight can be obtained by getting the ratio of weight and volume. No? Ratio of weight to volume. So in this case, we have weight over volume, and the weight is 47 over 6 cubic meters, 47 kilonewtons over 6 cubic meters. We will arrive with an answer of 7.833 kilonewtons per cubic meter. Okay, so that is our final answer for finding the specific weight of the substance. Next, we are interested now in finding the density of the of oil. Now, recall this equation. The specific weight is equal to the product of the density of the substance and acceleration due to gravity. No? So in this case, we are going to solve for rho. So we can able to rewrite this equation in terms of rho equals gamma over g. Okay? So this is the formula now in finding the density. Okay? Excuse me. In finding the density, so we have gamma over g, so which is the specific weight of 7,833 newtons per cubic meter. Okay, so I expressed the specific weight in terms of newtons per cubic meter. Then I divide it by acceleration due to gravity of 9.81 meter per second squared, and I will obtain an answer of 798.5 kilograms per cubic meter. So that's the unit of specific weight. So if we will analyze the so sorry, that is the unit of density. Okay, 700 kilograms per cubic meter. We know that density is mass over volume, right? That's why we have a mass and a volume. Okay. Now, how did we arrive with kilograms per cubic meter based from the given units? So let's apply unit tricks, no? So I have here Newton per cubic meter. I have meter per second squared. So by loss of fractions, if I have A over B all over C over D, so that is A over B times the reciprocal of C over D, which is D over C. So applying, we have Newton per cubic meter times second squared per meter, right? So I will arrive with Newton second squared per meter to the fourth. Recall, no? Recall that 1 Newton is 1 kilogram meter per second squared. Okay, this was discussed in physics, right? Because remember Newton's second law of motion. The force equals to the mass times the acceleration, right? So the net force, summation F, the net force equals to the product of the mass and the acceleration. So in here, SI unit, if we are considering SI unit, so this will be in kilogram, this will be in meter per second squared, arriving with this. So a unit of, which is a unit of Newton for the product of kilogram and meter per second squared. Knowing that, so we can able to rewrite. So I have kilogram meter per second squared times second squared. Kilogram meter per second squared times second squared over meter to the fourth. So cancel meter squared, right? Newton is kilogram meter per second squared, then there's another second squared. So and then meter and meter to the fourth, no? So this will now become kilogram per cubic meter. Cancel yung isang m, right? M to the fourth. So kilogram per cubic meter. Okay? Okay, so we proceed. Find the specific gravity now. So this is the formula for the specific gravity. I have discussed this previously. So in finding the specific gravity of this substance, I can get the ratio of the two, which is gamma over gamma of water at 4 degrees Celsius. So gamma of oil, gamma of the specific weight of the substance over the specific weight of water at 4 degrees Celsius. This is our reference specific weight. So the obtained specific weight is 7.833 kilonewton per cubic meter, and I will divide that by the specific weight of water at 4 degrees Celsius, that is 9.81 kilonewtons per cubic meter. I already introduced this in my previous discussion, no? And in this case, the specific gravity is equals to 0.7985, no? So what's the implication of a specific gravity of 0.7985? It implies that the specific gravity of oil, so this is the specific gravity of oil, and it is lower than 1. Note that the specific gravity of water is 1, no? At this temperature, 4 degrees Celsius, the specific gravity of water is 1. Okay? So if the specific gravity of oil is 0.7985 and it is less than 1, we can therefore say that oil is less dense, no, than water. So ibig sabihin, kapag ka naghalo yung dalawang likido, no, mapupunta sa taas yung oil, sa ibaba naman yung water dahil more dense ang tubig, or masasabi natin less dense ang oil kumpara sa tubig. Kaya nandito yung oil, tapos nandito yung water. So meron kang oil, meron kang dito naman meron kang water. Okay? Pag naghalo yung dalawang liquid. Okay. So we proceed, no? Number 2. So water weighs 4.08 pounds. compute the mass in slug, mass in kilograms, and volume in cubic foot. Okay, so water weighs 4.08 pounds. Okay, and we are required to find the mass in slug, mass in kilogram, and volume in cubic foot. So recall that weight is equals to mass times acceleration due to gravity, right? This was discussed in physics. And in obtaining for the mass, we get this equation. No? We derive this equation from W equals mg, which is m equals W over g. Okay, so the weight is 4.08 pounds. Okay, acceleration due to gravity. So we have here British gravitational units. So this were used, British gravitational units. So I have here pounds. Therefore, the corresponding acceleration due to gravity is in terms of feet per second squared, which is 32.2. No? That is 32.2. So what will be our answer? Our answer is 0.127 slug. Okay? So note, okay, that for every slug there is 1 pound second squared per foot. Now 1 pound second squared per foot. So if we analyze this the units, so this is per second squared, so uh, it will be transferred in the numerator, and what is left in the denominator is foot. So that makes the unit now to be slug. Okay, that makes the unit to be slug. All right. Take note that this pound is a unit of force. No, this is a unit of force. Okay, take note of that. So we proceed. Now we are to get the mass in terms of kilogram, and take note, okay, that for every slug there is 14.59 kilograms. Okay, for every slug there is 14.59 kilograms. So remember that conversion. Okay, so one slug is equals to 14.59 kilograms, and we get an answer of 1.85 kilograms. So in other words, if the weight of water is 4.08 pounds, the corresponding mass in terms of kilogram will be 1.85. No? So 1.85 kilograms. Then C, volume in cubic foot. So recall that the density of water is can be obtained using the formula mass over volume. So rearranging this equation, we get volume equals mass over density. Okay, and in that case, we know that we have we have to determine raw of water at a certain temperature. So as you notice, the temperature in the problem was not mentioned. Sorry, there's no mentioned temperature in the problem, right? So if there's no mentioned temperature in the problem, you can use the standard density, no? Which is measured at a temperature of 4 degrees Celsius. The standard density of water is 1,000 kilograms per cubic meter, 1.94 slug per cubic foot, no? So 62.4 pounds per cubic, sorry, not that one, that specific weight. So dalawa, no? 1.94 slug per cubic foot. Okay? And bukod dyan, we have 1,000 kilograms per cubic meter. Okay? All right. So that's it. So we have now 0.127 slug over 1.94 slug per cubic foot. This was discussed in my previous video, no? So 0.127 slug over 1.94 slug per cubic foot for the density of water at 4 degrees Celsius. Okay? So mass is 1.94 slug, volume is cubic foot, no? So we will obtain an answer of 0.0655 cubic foot. Okay? So cancel. Then what is left is cubic foot. So it will now be in the numerator, no? So applying laws of fractions. So or the other way around, we can use the formula. The specific weight is equals to the ratio of weight to volume. So we have the volume can be obtained by dividing the weight to the specific weight, no? And we get, so take note, the specific weight that we will consider here must we'll use the standard, no? The specific weight that we will consider here is the standard specific weight, which is measured at a temperature of 4 degrees Celsius for water. Okay? So in here, we have 4.08 pounds. We know the weight. And take note that the specific weight of water is 62.4 pound force per cubic foot. Okay? This is 62.4 pounds per cubic foot. I have already introduced this in my previous video that the specific weight of water at 4 degrees Celsius is 62.4 pounds per cubic foot. And that will give us a unit of 0.0654. No? Okay? That will give us an answer of 0.0654 cubic foot. No? So as you notice, there's slight difference, right? So it's just okay. Ano? Dahil ginamit kasi dito ay slug. Ito ay pounds. Kasi actually meron pang decimal yan eh. No? 1 point, hindi yan saktong 1.94. Hindi rin to saktong 62.4. Kaya nagkakaiba ng bahagya, no? So pero ang kino-consider lang kasi natin dito ay 3 significant figures, no? 3 significant. So meron ako ditong 194, 3 significant na 'yon. 624, 3 significant na 'yan, no? So it's just okay for as long na tama yung ginamit na mga constants, no? So number 3, what is the specific weight of air at 480 kilopascal absolute and 21 degrees Celsius? The gas constant R for air is 287 joule per kilogram Kelvin. So we have the pressure of 480 kilopascal, and it is expressed in absolute. So recall your thermodynamics, no? You have studied about absolute pressure, no? So in that case, kilopascal absolute, so kPa, no, for absolute pressure, no. And then the temperature is also given at 21 degrees Celsius. And the gas constant for air is given at 287 joule per kilogram Kelvin, no. So with that, let's recall the formula for the specific weight. This is required in the problem. The specific weight of air, denoted by gamma. So recall that the specific weight of a substance can be obtained by multiplying the density of the substance to acceleration due to gravity. So recall ideal gas equation. So recall in thermodynamics, the product of the pressure and the volume is equal to the product of the mass of the substance, the gas constant, and the absolute temperature. Take note, P here is absolute also, no? Absolute pressure. And in this case, we have P over RT. Rearranging this equation, PV equals MRT. PV over RT equals to M over V, right? So M over V, P over RT. M over V is density, no? M over V, that is density of the substance, denoted by rho. That's why rho now is replaced by P over RT, which is this. Okay? So this is a lesson in thermodynamics, right? So in this case, so this will now be the values. So the pressure is 480,000. So we get rid of kilo. So we express that in terms of, so instead of kilopascal, Pascal. So expressing it in Pascal, note, okay, for every Pascal, that is 1 Newton per square meter, no? This me? For every Pascal, that is 1 Newton per square meter. Okay? So that's why this is now 480,000. Instead of writing Pascal, I write Newton per square meter. And then I have, excuse me, acceleration due to gravity of, so this is the standard acceleration due to gravity that we're going to use, no? 9.81 meter per second squared. Excuse me. So in that, then we have the gas constant of 287 joule per kilogram Kelvin. Take note that 1 joule is 1 Newton meter, no? 1 joule is 1 Newton meter. That's why it becomes Newton meter. Okay? So, and then I have here absolute temperature, that is 21 degrees Celsius, adding by 273, we get in terms of Kelvin, so that it will become an absolute temperature. Okay? We add 273 to 21 degrees Celsius, no? So, cancel, no? Cancel. Then, so let us analyze. So what will be left? No? So, na-cancel na yon. Unit tricks tayo, 1 over square meter times meter per second squared. Dito naman, pwedeng i-cancel to. Meter. Okay? So, mawawala ng unit yon. 1 na lang nun. Okay? And then, ano pa? Ito, kilogram. So, meron dito 1 over kilogram. Okay, nawala. 1 over kilogram. So, ayusin natin. So, 1 over square meters second squared. 1 over kilogram. So, magiging kilogram. So, dahil 1 over kilogram yan, by laws of fraction, mapupunta siya sa numerator. Kaya kilogram per square meter second squared. Okay? So, alam natin that ano dapat ang in-expect nating unit dito? Specific weight. Ang specific weight is weight over volume, right? Ang in-expect nating sagot, kung SI system tayo, weight in Newton, volume in cubic meter. No? Paano natin mapapalabas yung Newton per cubic meter given na kilogram per square meter second squared? Recall ulit natin, no? So, alam natin that 1 Newton is equals to 1 kilogram meter per second squared, no? Okay? 1 kilogram meter per second squared. Okay. So, therefore, kung magmumultiply ako ng meter over meter, di ba ang meter over meter is 1? Okay? Ibig sabihin yan, no violation. Kasi 1 naman yan eh. Meter, mag-multiply ako ng meter over meter. So, pag ginawa ko yon, makakuha ko ng kilogram times meter, kilogram meter, okay? Tapos, meter squared meter, meter cube, right? Tapos, meron ditong second squared, okay? Meter squared meter, meter cube, then second squared, okay? So, tapos, I can rewrite, no? Itong kilogram, meter, tapos meron doon second squared, pwede ko siyang ilagay sa numerator. Kilogram, meter, per second squared. Imbis na nandito siya, pwede nandito sa numerator na nasa denominator. Tapos, nasa ibaba ng meter, no? Ayan, meter over second squared. Then, cubic meter. Okay? Ayan. So, kilogram meter per second squared, ayan, which is now a unit of Newton. Ito yung Newton. Ayan. Di ba? 1 kilogram meter per second squared is 1 Newton. So, Newton na yan. Newtons per cubic meter. So, kaya ang sagot ay 55.8 newtons per cubic meter. I hope you get it, no? So, we proceed. Number 4. Find the mass density of helium at a temperature of 4 degrees Celsius and a pressure of 184 kilopascal gauge if atmospheric pressure is 101.92 kilopascal. For helium, we have R equals to 2079 joule per kilogram Kelvin. Okay, let's analyze. So, the given are as follows. The temperature is 4 degrees Celsius. Okay. The pressure is 184 kilopascal gauge. Okay. And then the atmospheric pressure is 101.92 kilopascal. The gas constant for helium is 2079 joule per kilogram Kelvin. And we are tasked to find for the density of helium. Okay, so let's analyze. So, resolution, recall that in thermodynamics, you have learned that, if I'm not mistaken, no? And this should be discussed in thermodynamics. In finding the absolute pressure, okay, we just add the gauge pressure and the atmospheric pressure, no? So, this was discussed in detail in thermodynamics, no? So, the absolute pressure is of a substance, no? Absolute pressure is equals to the gauge pressure of the substance plus the atmospheric pressure. No? So we know that P here is absolute. So we have to add gauge and atmospheric to get the absolute pressure. And this is also absolute, the temperature, which is we have to add 273 to make it Kelvin, to make it absolute temperature. Now, so with that, we have here the pressure should be in absolute form. So the kilopascal gauge, so which is 184,000 Pascal, and Pascal is converted to Newton per square meter because 1 Pascal is 1 Newton per square meter. And we add the atmospheric of 101,920 Pascal or Newton per square meter. No? So, and then, so that this will now be absolute. No? This will now be in absolute form. The pressure is now in absolute form, adding the atmospheric pressure and the gauge pressure. Okay? Then we divide it by the gas constant for helium, 2079 joule is 1 Newton meter. Okay? The kilogram Kelvin. Then we multiply it by absolute temperature, which is the temperature is 4 degrees Celsius, adding by 273. That will now be converted to Kelvin. Okay? And what will be our final answer? So let's analyze what will be the unit. Newton, Newton, cancel. Kelvin, Kelvin, cancel. Okay. So the answer is 0.496 kilograms per cubic meter. 0.496 kilogram per cubic meter. So let's analyze. Paano siya naging kilogram per cubic meter base sa mga unit na meron tayo? So we have here, na-cancel yon 1 over square meter. Meron ka meter dito. Over, cancel, cancel, meter over kilogram. Diba? So, that is 1 over square, by loss of fraction, 1 over square meter times kilogram per meter. Kaya, kilogram per cubic meter. We are multiplying meter squared and meter cubic meter. So, that's the answer. That's the unit. No? Okay? So, let's now study about surface tension. This is another property of fluid. No? When we talk about surface tension, it is the contractive tendency of the surface of a liquid that allows it to resist an external force. Okay? Contractive tendency of the surface of a liquid that allows it to resist an external force. Let me give you an example. What have you noticed here? Alam natin, ang bakal, ang metal ay ay more dense than water. Diba? Ibig sabihin yan, ang specific gravity ng metal na yan ay greater than 1. So, dapat lulubog yan. Magsisink yan dapat. However, may exemption sa rule. Meron, dapat, depende sa sa posisyon na nilagay, di ba? Depende sa posisyon. So, sa ganyang posisyon, di siya lulubog. No? Dahil, may property yung ating liquid na tinatawag na surface tension. Contractive tendency. Nagko-contract yung mga molecules ng liquid na to. Okay? Contractive tendency of the surface of a liquid that allows it to resist an external force. Meron kasi silang cohesive property. Yung mga molecules ng isang liquid. No? So, in this case, meron na ang surface tension ngayon ay isang property ng liquid na kung saan nire-resist niya yung isang external force. Nire-resist niya yung external force na ina-apply, no? Doon sa surface ng liquid na yon, no? Okay. So in other words, so later sa next slide, ano yun natin yan? I-expound ko pa yon, no? So in this case, may mga insects na nakaka hindi sila lumulubog pagka hindi sila nagsisink pagka nakaapak sa tubig, no? Bakit? Dahil sa property ng tubig na to, kung saan siya nakaapak, or any liquid, na surface tension, which is the contractive tendency of the surface of a liquid, no? So, yung mga molecules ng liquid kasi, no, ano yan, nag-exert ng attractive force sa kada molecule. Nag-exert yan ng attractive force. Halimbawa, kung ito yung molecule ng liquid, o ito another liquid. So, i-attract niya, itong molecule na to, i-attract niya yung another molecule. Ganon din siya, yung molecule na to, i-attract niya din ito sa ganitong direction. Meron kang tinatawag na cohesive force, no? So, may tinatawag na cohesive force. Okay? So, marami yan. Maraming molecule, ina-attract nila yung bawat isa, no? Okay? So, ina-attract nila. So, para lang ano yan, blanket, no? Kung halimbawa, meron akong blanket. Okay? Kung meron akong blanket, pagka naglagay ako ng bato at hindi nakayanan ng blanket yung bigat ng bato, lulubog siya. Ano mangyayari sa blanket? Gaganyan, di ba? O, ito yung bato. O, pag hindi nakayanan ng blanket yung bigat ng bato, lulubog siya. Mapupunit yung blanket, magkakabutas. Okay? Pag hindi nakayanan. So, ganun din dito. So, kumbaga, merong certain amount of force bago lulubog yung isang bagay, no? Dito sa liquid na to. May certain amount of force na i-consider bago lulubog, no? So, let's continue. So, as I have said in my previous slide, no? Contractive tendency ng isang substance, no? So, na nire-resist yung external force, no? So, that is surface tension. Another definition of surface tension, it is the property of the surface of a liquid to resist external force due to cohesive nature of its molecules. So, ito, nabanggit ko na yan. Yung cohesive force. Kaya, nagkakaroon ng contractive tendency dahil may cohesive nature yung mga molecules ng isang liquid, no? Okay? So, pansinin natin, no? So, kung ito yung bagay na nilagay dito sa body of liquid, no? Okay? So, nagkakaroon ngayon ng surface tension dito, tsaka doon. Okay? Nagkakaroon ng surface tension. Okay? So, sabihin niyan, nire-resist niya yung bigat ng bagay na nakapatok dito sa tubig. So, pag hindi niya na-resist, magsisink. Magsisink itong bagay na to. Gaya ng karayom, no? Let's say ito ay karayom. Okay? So, magsisink yan. So, kumbaga, ito yung length ng karayom. Nandito yung length niya. Okay? So, pag hindi nakayanan, magsisink. So, pag sinabi natin cohesion, it is the attraction between two like particles or molecules. So, attraction between two like particles or molecules. Kaya kung mapapansin nyo, halimbawa, umulan, kung ito yung isang dahon ng isang halaman, may mga namumuong tubig, namumuo, di ba? Yan, namumuong tubig. Kasi umulan, tapos may mga namumuong tubig dun sa dahon. Okay? So sabihin niyan, there is surface tension. Okay? There is surface tension dahil yung mga molecules ng tubig na yan na namumuo, ina-attract nila yung kada isa. No? Nag-attract sila. No? Ina-attract nila yung bawat isa. Kaya namumuo sila. So dahil na-attract nila yung kada isa, okay, nagkakaroon ngayon ng pressure sa loob. Sa loob ng namuo na yan, merong pressure. At yung pressure na yan, nagkakaroon ngayon ng surface tension. No? Sa surface ng namuong tubig na yan. No? Nagkakaroon ng surface tension. Kasi may pressure sa loob eh. No? Nagkaroon ng pressure. Okay? Pag hindi nakayanan ng pressure, mag-expand yan. Mag-expand. Yung tubig na yan. Okay? Mag-expand sa dahon niya. Okay? So, yun, no? So, we have ating analysis. Kung ito ay water droplet, okay? So, may mga molecules, itong water droplet na yan, let's say yung namuong tubig. So, droplet, tatawagin natin droplet, no? Okay? So, ito yung kanilang, so, ibig sabihin yan, itong molecule na to, ina-attract siya nung kabilang molecule. Katabi niya pa rito, next to it, ina-attract niya. Tapos yung mga sa ilalim niya, ina-attract din siya. Okay? Yan, no? Tapos yung sa bandang ilalim naman ng water droplet, yung molecule na to, ina-attract nito. Okay? In all their directions. Okay? So, ganun siya. Alright? So, kaya nagkakaroon ng ganitong form. Spherical form ng water droplet. No? Dahil nagkakaroon ng attraction between two like molecules, which is molecules of water, dito sa example natin. No? Okay? So kung maglalagay ako ng object dito sa water droplet, halimbawa, okay, hindi basta-basta ma-deform itong water droplet. Hindi basta-basta mag-expand, no? Pag naglagay ako ng object. Dahil sa property niya ng surface tension. Pinapanatili ng mga molecules ng tubig na yan na hindi maghiwalay. Pinapatili nilang hindi maghiwalay dahil yun ang kanilang nature. Meron silang cohesive nature. Ina-attract nila yung kada isa na para silang glue. Okay? So, that's it. So, pansinin natin, may karayom na nakalutang sa tubig na to. No? So, ba't siya lumutang? Dahil sa property ng tubig na surface tension. So, sabihin niyan, kung consider natin yung length na yan, nagkakaroon ng surface tension dyan. Okay? Nagkakaroon ng surface tension dun sa part na in contact with water, yung karayom. Nagkakaroon ng surface tension. So, merong force. Merong force. Okay? Ganon din sa kabilang side. So, nagkakaroon ng surface tension. Okay? Nagkakaroon ng surface tension dun sa kabilang side. Yan. Ngayon, pag sobrang bigat na yan ng karayom, lulubog na siya. Hindi na kaya ng kumbaga na overcome na yung force, maximum force, no? Due to surface tension. No overcome no? Nitong karayom. So pagka yung weight masyado mabigat, may tendency na hindi na kayang i-support ng surface ng tubig, no? So, di sabihin nun, magsisink siya. Okay? So, consider natin itong view na yan, view ng karayom. Okay, consider natin yung view ng karayom. So, nandito ngayon yung haba ng karayom. Yan. Okay. So, tapos, nandito yung mga forces magkabila. Tapos, parang siyang blanket. Parang blanket ng tubig. Yan. Yan. So, sabihin yan, gaganon siya. Okay? Gaganon. So, nang magkakaroon ng deformation sa part ng surface. Yan. Okay? So, hanggang sa lumubog pag hindi nakayanan. No? So, in that case, ito yung weight ng ating needle. Tapos, ito yung surface tension. Ito yung force due to surface tension. No? Yan ang force due to surface tension. Okay? In all directions yan. No? Yan. Pinagsama na lahat yan sa haba nito. Okay? And then, ito yung kanyang length. Length ng karayom. No? So, ibig sabihin yan, ito yung ating pagkuha ng coefficient of surface tension by formula, no? Which is force due to surface tension over the length. No? Ganun lang ang formula na pagkuha ng coefficient of surface tension or surface tension. No? So, in this case, force over length. Ganyan lang siya. No? Force over itong length na yan. So, yun ang ating surface tension. So, consider natin na itong karayom ay isang particle. Okay? Isang particle. So, ito yung mga forces acting on the particle. With an angle, okay? Forces acting on the particle with an angle. So, parehong angle yan. No? So, parehong angle theta. Okay? And then, ito yung kanyang weight. Okay? So, let's answer a problem regarding this topic, which is surface tension. So this is the problem. We have a 5 centimeter long needle is to be placed on a surface of water without sinking. The temperature of water is 20 degrees Celsius. Find the mass of the needle to be placed just before it will sink. B. If the mass of the needle is 0.500 gram, determine the contact angle with the vertical angle between the needle and the water surface. So we have a 20 degrees Celsius surface tension. Okay, water with air. So yung coefficient of surface tension or surface tension na lang. So water with air is 0.0728 Newton per meter. So by the way, this is the Greek letter sigma, no? Greek letter sigma. All right. So ito yung ating needle, 5 centimeter long daw, no? Is to be so ibig sabihin nito, sa temperature daw dito ay 20 degrees Celsius. The temperature of water is 20 degrees Celsius. Naka naka-place yung needle sa surface ng tubig. So ano daw yung mass ng needle bago ito lulubog? So sabihin, let's find the maximum mass na possible para ma-maintain niya yung ganitong posisyon, itong needle. So let's analyze. So etong view na yan ng needle, so ibig sabihin nandito yung kanyang length. Okay? So nandito yung kanyang length. So with that, ito yung kanyang weight, force due to surface tension, force due to surface tension. So yan yung ating needle. Okay. So with that, ito yung nahanap natin. Ano daw yung maximum mass? O para malaman natin yung maximum mass, ano yung magiging angle kung maximum mass ang hahanapin natin? Ano mapapansin nyo pagka bumibigat ng bumibigat yan? Lalalim ng lalalim yan, right? Lalalim ng lalalim hanggang mapunit na. Hanggang mapunit na yung surface na yan. Mapupunit na yung surface. Okay? So, sabihin niya, nagkakaroon ng tension sa surface. Kasi, pagka hindi nakayanan ng yung bigat na nilagay dyan, bibigay yung surface. Mahuhulog sa ibaba yung bagay na to, which is yung kalayo. So, nagkakaroon ng tension sa surface ng water. Surface tension, no? So, theta is, pag lumalim ng lumalim, ano mapapansin nyo? Lumiliit yung angle. Liliit yung angle na yan. Yung pagitan niya, sabihin yung force natin, ganyan. So, nagiging vertical. Diba? Kasi, lumalalim eh. Okay? Lumalalim. Yan. So, that's the tendency. So, sabihin na, nandito yung force na yon, tsaka nandito yung force na yon. So, hindi na katulad dito. So, sabihin niyan, pag naging zero yung angle, lulubog na siya. Mag-start na siyang lulubog. No? Mag-start na siyang mag-sink. Ayan. If the angle is zero, it will start to sink. No? Sabihin, tuluyan nang mapupunit. Tuluyan nang mapupunit yung surface, no? So, this is the maximum weight. Kung meron kang maximum mass, meron kang maximum weight. So, ito yung itsura ngayon. Pag yung angle ay 0, so diretso yung dalawang forces due to surface tension. Okay? Magkabilang side kasi, may surface tension dyan. May force due to surface tension. No? Magkabilang side. Okay? So, with that, how will we solve the problem now? So, anong goal natin? Mass. Mass ang goal natin. So, in this case, bago siya mag-sink, nasa equilibrium condition, right? Yung ating needle, equilibrium. It is at rest. No? Bago siya mag-sink, it is at rest. So therefore, we'll apply Newton's first law of motion. Okay? Newton's first law of motion, applying that, so we have summation forces vertical equals 0. No? Summation forces vertical equals 0. So, applying Newton's first law of motion, we can sum up forces along vertical equal to 0. No? So, sabihin niyan, FST plus FST minus W max, no? So, equals to 0. Okay? And 2FST equals to W max. So, we know that the weight maximum is the maximum mass times acceleration due to gravity. So, divide natin ang acceleration due to gravity on both sides. We get the maximum mass. So, 2FST over G. Recall natin yung surface tension formula. Okay? Force due to surface tension over the length. Okay? Force due to surface tension over the length. So, ito yung FST, express natin in terms of the surface tension and the length. No? Surface tension coefficient and the length. So, the maximum mass now, in terms of surface tension and length, so 2 coefficient of surface tension times the length over G. So, ito, na-converted ng ganito. Okay? So, surface tension, water with air at 20 degrees Celsius. This was mentioned in the problem, 0.0728 Newton per meter. So, kung yan yung yun yung given natin, so nagkakaroon ng certain mga forces. Okay? So, dalawang side, yung may surface tension force. Okay? So, dalawang side. Okay? So, ito. So, mayroon kang surface tension force. Surface tension force. Okay? So, tapos divide mo to sa length. Yun na yung coefficient of surface tension. Okay? So, we have 2.0728 Newton per meter. Yung length ay 5 centimeters. That is 0.05 meter. Acceleration due to gravity is 9.81 meter per second squared. And this is our answer. 7.42 times 10 to the negative 4 kilograms. Kilogram. Or, pwede natin convert ng gram, 0.742 gram. Okay? So, ang kilogram ay 1,000 grams. Yung 7.42 times 10 to the negative 4, multiply mo ng 1,000 para maging gram, no? Which is 0.742 gram. So, ganyan lang yung bigat bago siya mag-sink yung needle, no? 0.742 gram, no? Okay? So, that's the maximum mass. So, bago mag-sink yung ating needle. So, B, if the mass of the needle is 0.5 gram, ibig sabihin yan, mababa dun sa 0.7 something. No? 0.7 0.742 gram. O kung 0.5 gram lang. O kung 0.5 gram lang, anong hinahanap? Ano yung contact angle with the vertical? Angle between the needle and the water surface. Okay? So, sabihin niyan, ito yon. So, ito yung ating 0.5 gram. No? O, ito yung hinahanap natin. Ano yung contact angle na yan? With the vertical. Okay? With the vertical. Determine the contact angle with the vertical angle between the needle and the water surface. Okay? Nandito yung needle, water surface, needle and water surface. Correction lang, hindi siya needle and water surface kasi nandito yung ating water surface. Hindi ko na-edit yung problem. Sorry. Wait lang ha. So, needle and water surface. Angle between the needle and the water surface. Hindi na kailangan ito kasi vertical na yan. Determine the contact angle with the vertical. So, contact angle with the vertical. Okay. Hindi na kailangan to. Okay? So, yan. Hindi ko na-edit. Ayan. Okay, so we proceed. Ayan, no? So, with that, so ito yung nahanap natin. Determine the contact angle with the vertical. Ito. Okay? Pag sinabing contact angle with the horizontal, ito yung hinahanap. No? Ito yung hinahanap. Contact angle with the horizontal. Ito yung hinahanap. So, sabihin, between yung karayom at yung tubig. Between yung karayom at saka yung tubig. Okay? Pagka horizontal. Okay? So, that's it. So, sabihin niyan, yung vertical, air. Air and yung karayom. Vertical, no? So, air at saka yung karayom. Dito. Okay? So, we proceed, no? So, again, apply natin yung Newton's first law of motion. We can sum up forces vertical equal to 0. So, paano siya naging FST cosine theta? So, FST, so pag cosine theta, so recall natin yung SOHCAHTOA, no? SOHCAHTOA. So, pag cosine, adjacent over hypotenuse. So, kung mapapansin natin dito, ito yung FST. Okay. Nandito yung angle. Ito yung, kung yung angle na yan, ito yung magiging adjacent side. Ito yung magiging adjacent side. Ito yung magiging opposite side. Ito yung hypotenuse. Okay? Ayan. So, kung ganyan, ang cosine mo ay formula, SOHCAHTOA, adjacent over hypotenuse. Adjacent over hypotenuse. Kaya, ano yung adjacent side? Adjacent, no? So, yung adjacent side over hypotenuse natin is FST. Kaya yung adjacent side na to, no, itong adjacent side dito, Yung adjacent side dyan ay FST times cosine theta. FST cosine theta. Ayun. So, yung adjacent na yan, component ng FST na vertical. Ito yung vertical component ng FST. Okay? So, FST cosine theta. Okay? So, tapos, similarly, yung kabilang side, ganun din. Ito yung FST, ito yung angle, ito yung adjacent side, summation forces vertical kasi, ito yung FST cosine theta, ito yung FST sin theta. Okay? Ganyan siya. Automatic na ganyan, no? Pag nandito yung angle, no? Pag nasa vertical. So, yung kabila, dito yung angle, ito yung ating FST. So, this is FST. Okay, opposite, so sine. Nandito yung adjacent, so cosine. Okay? Kaya FST cosine, FST cosine. Kasi along vertical yung ating concern. Right? So, ito yung FST cosine plus FST cosine. Minus yung weight. Okay? Napababa. So, 2FST cosine theta equals W. Transpose natin yon, maging ganyan. Then, arranging, we have weight is mass times acceleration due to gravity over 2FST. Okay? So, then, kunin natin yung arc cosine. Okay? So, para makuha yung angle, arc cosine natin yung mg over 2FST. So, alam natin yung FST ay product of coefficient of surface tension and the length. No? Or surface tension and the length. mg over 2 sigma STL. So, ito yon 0.5 gram. Ang 0.5 gram ay 0.5 times 10 to the negative 3 kilogram. Then, G is 9.81 meter per second squared. Sigma ST, given na yon, 0.0728 Newton per meter. Length is 5 centimeters. So, with that, our answer is 47.8 degrees. Okay? So, sabihin yan, 47.8 degrees. No? Yung angle na to. Pag may bigat, pag may mass yung karayo na 0.5. No? Pagka yung kanina, 0 yung angle na 0.74 something. 0.74 something. Ito, 0.742 gram. 0 yung angle. Pero pag 0.5 gram lang siya, yung angle na to ay almost 48 degrees. No? Almost 48 degrees. Or 47.8 degrees. Okay? So that's it. So that ends my presentation. So that's all for today. Okay, good day everyone.